Solution to a 3-mark question from Trigonometry. This is question number 30. Question has two alternatives, 1 and 2. Both these alternatives involve proving two trigonometric identities. Let's get started with the first one. The LHS of the first alternative is cot A minus cos A upon cot A plus cos A. We'll have to prove that this is equal to cosecant A minus 1 upon cosecant A plus 1. First of all, what is cot A? Cot A is equal to cos A by sin A and cosecant A is equal to 1 by sin A. So first step, let's replace the cot A both in the numerator and denominator of LHS as a cos A by sin A. So when we do that, what we'll get is cot A is a cos A upon sin A minus cos A, this is the numerator, right, divided by cos A by sin A plus cos A. Let's look at it. There's a cos A term in the numerator in both parts. In the denominator of both parts as well, we have a cos A term. So let's take the cos A common both in the numerator and in the denominator. So what will be left is this cos A into 1 upon sin A minus 1. Cos A has been taken common outside. Let's do that for the denominator too. Cos A into 1 by sin A plus 1 is what we have. Cos A gets cancelled with cos A both in the numerator and denominator. What we are left with is 1 by sin A minus 1 divided by 1 by sin A plus 1. 1 by sin A we know is a cosecant A. Let's write this 1 by sin A as a cosecant A. So cosecant A minus 1 divided by cosecant A plus 1. This is the RHS that we have to prove. So LHS equals RHS. Quickly summarize it in a printed form. We are writing cot A as a cos A by sin A in both the numerator and denominator. Taking the cos A term common for the numerator. Taking the cos A term common for the denominator. Cos A gets cancelled with cos A. So what will be left with is 1 by sin A minus 1 upon 1 by sin A plus 1. 1 by sin A is a cosecant A. So that's the RHS. Let's move on to the second alternative, which is equally as easy as the first one. We know tan A is equal to sin A by cos A. And we know secant A is equal to 1 by cos A. What we need to prove is tan A minus sin A divided by tan A plus sin A is equal to secant A minus 1 by secant A plus 1. The LHS, let's start by rewriting this tan A as a sin A by cos A, as much as exactly the same way what we did in the first part, right? Alternative 1, we wrote the cot A as cos A by sin A. Here we are writing the tan A as a sin A by cos A. So tan A can be replaced as sin A by cos A minus sin A. So this is our numerator divided by the denominator tan A can be written as sin A by cos A plus sin A. Take sin A common from both these terms in the numerator. Take sin A common from both these terms in the denominator. So if we take sin A outside, we'll get sin A into 1 upon cos A minus 1 divided by, again sin A common from the denominator will leave us with 1 by cos A plus 1. Sin A in the numerator and denominator get cancelled. 1 by cos A is a secant A. So let's write this 1 by cos A as a secant A. So secant A minus 1 divided by secant A plus 1. That's the RHS we have to prove. Quickly summarize it in a printed form. We have rewritten this tan A as a sin A by cos A both in the numerator and denominator. Next step, we'll take sin A common outside. So we'll get 1 by cos A minus 1 by 1 by cos A plus 1 after cancelling the sin A's. 1 by cos A is nothing but secant A. Secant A minus 1 by secant A plus 1. LHS equals RHS. Before you leave, do two things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. It takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.